Hey guys, my name is Uncle Han. So today we're gonna be checking if the system is in a safe state or is not, and if there are deadlocks occurs or not. So these are the questions that have been provided. I'm going to do the question 1 to question number 3, and the question number 4 will be done by another member. So the first question is asking me to calculate the available resources. So these are the table that have been provided for the question, and this is the maximum and current allocation and the total resources or instances. So how do you calculate the available resources? For the available resources, you look at here, you need to take the instance minus with the current allocation. So the total instances is R1 and is 15, and R2 and 6, R2 is 9, and R4 is 10. And for the current allocation is R1, there are many tables, is P0 to P5, and R2 is P0 to P5 too, R3 is P0 to P5, R4 is P0 to P5 also. So how do I get the 9 over here? The 9 over here. And the 15. The instances, for the R1, the R1 right here, you need to calculate a variable for the R1. You get the 15 from the instances R1 right here. 15 instances from R1. And how you get the 9? You get the 9 from the R1, the total of the P0 to P5 of R1. You total up the 2, 0, 4, and 1, and 1, and 1, and you get the 9. And you minus it. You take the R1 of these instances, 15, and minus with the total up of P0 to P5 R1, and you get the 9. You take the 15 minus 9 equals 6. That is the available for the R1. Here, you get the 6 right here. So you do that for R2 also. You take the 6 total instances for R2 is 6 right here, and you take the 3. How do you get the 3? Is you total up the P0 to P5 of R2. You take the 0 plus 1 plus 1 plus 0 plus 1 and plus 0. You get the 3, and you take the instances minus current allocation, and you get the 3 for the R2 available right here, 3. So you do that for R3 and R4 also, and you get the R1 to R4 available. So that's all for the available resources. Let's move on to the question number 2. The question number 2 is telling me to calculate the content of the matrix need. So how do you get the matrix need? Is that you take the maximum here, right here, and minus the current allocation. You see right here, the P0 equals to 9 minus 2, 5 minus 0, 5 minus 2, 5 minus 1, and equals to 7534. How do I get the 7534 for the need of P0 right here of R1? You see, 9 minus 2. How do I get it? It's from max and current allocation. We see P0. We set max minus allocation. So we look at the max first. The R1 of P0 is 9. So you take the 9 from here, and you minus the 2 you take from the current allocation is R1 of P0 right here, the 2. You do that, you take the 9 minus 2, and you get the first need 7 right here. The second row is R2. You need to calculate for the R2 as well. You take the 5 minus 0. How do you get it? You take maximum first, 5, the R2, P0. You got 5, P0 to P5. You start from P0 first. You take the R2, 5, and you minus with the current allocation, P0, R2. You got the 5 here. And you need to do it for R3 as well. You take the 5, maximum of R3, the P0 is 5. And you minus it with the current allocation. R3 is P0, and R3 right here is 2. So 5 minus 2 equals to 3. And you do that for R4 as well. This is the R4. This R1, R2, R3 and R4. You take the R4 of P0 is 5. You take the R4 of current allocation, P0 is 1, and 5 minus 1 equals to 4. That's how you get the need. You do that for P1 as well, the second row. You take the maximum minus the current allocation. You take the R1 of P1. This is the P1 already. We go to the next row. So R1 of P1 is 2. And you minus it with the current allocation. P1 is 0, the R1. And you get the 2 for R1. The need for row 1 and P1. You get 2. So let's do that for the row 2 as well. You take 2 right here, P1 of row 2, and you take the P1 of row 2 is 2. So you get 2 minus 1 equals to 1. You get here the need of R2 right here. And you do that for R3 as well. You take the R3 P1 minus 3 and you minus it with the current allocation. R3 P1 is 1. You get 1. So you 3 minus 1 equals 2. So you do that for R4 as well. You take the R4 of P1 is 3. The R4 of P1 of current allocation is 1. And you take 3 minus 1 equals to 2 right here. And you do that for P2, P3, P4, and P5 also. I do this because I make it easier for me to look when I do for the question 3. 2 of this is linked to question 3. So let's move on to question number 3. Question number 3 is telling me to show that the current state is safe. Show a safe sequence of processes. In addition to the sequence, show how the variable changes as each process terminates. It's telling me is to show that the state is safe. So how to check the system is safe? We need to look at the P0, P1, P2, P3, P4, P5, all the processes. So how do you check it? Is you take the need and compare it with a variable. The need to be smaller or equal than a variable. So right here, if the above statement is true, then the process will terminate and the previously in use resources are made available again. You need to check the P0 if it's true or false. The process 0 right here. So how do you check it? Like I said, you need to compare with the need and the available. So the need of P0 is 7534. Just now we already calculated it. We take the 9 minus 2, 5 minus 0, 5 minus 2, and 5 minus 1. You get a 7534. And you compare it with the available resources right here. Just now, the question 1. We already calculated and we get the available is 6354. We take the P0, the need of P0, 7534, and compare it with the available is 6354. Right here, I already compare it. The need of P0 is 7534, and you compare it with the available right here, 6354. So you see the need of P0 is 7534 and the available is 6354, and you compare if 7 is smaller or equal than 6. No, it is not. 5 is smaller or equal than 3. No, it is not. 3 is smaller or equal than 5. Yes. And 4 is equal or smaller than 4. Yes. So there are 2 yes and 2 no. The process is still gonna be false. It need to all be the true one. It need to be smaller or equal. So if the process is false, we move on to another process first. We move on to the P1. For the P1, you take the need again and you compare it with the variable right here. The need of P1 is 2122. 2122. I already do it right here. 2122. And compare it with the variable 6354. And you get 2 is smaller or equal than 6. Yes. 1 is smaller or equal than 3. Yes. 2 is smaller or equal than 5. Yes. 2 is smaller or equal than 4. Yes. So the process is true. If it's true, you need to take the available and you plus it with the current allocation of P1. How do I get this here? Is the right here. I get it from here. current allocation of P1 is 0, 1, 1, 1. So 0, 1, 1, 1. You take the available plus with the current allocation and you get 6, 4, 6, 5. So after you get this, you need to make a new available. You cannot use the old available again. You need to use the new available for the next process to use. So after you get this, you move on to the P2. So 3 P2, again you take the need and you compare it with the new available right here. Just now you already plus with the current allocation of P1 and you get the new available right here 6, 4, 6, 5, and you take the need right here 3, 4, 2, 2 and you compare it with the new available right here. So new available is 6, 4, 6, 5 and 3 is smaller or equal than 6, yes. 4 is smaller or equal than 4, yes. 4 is smaller and equal to 6, yes. 2 is smaller or equal to 5, yes. So the process is true. If it's true, again you take the available, the new available right here, and you plus it with the current allocation of P2 right here. Current allocation of P2 is 4102. 4102 right here, 4102. So equals to 10, 5, 6, 7. And this is the new available for another process to use again. You need to use the new available. And you do that for P3 as well. If it's true, then you take the new available plus with the current allocation of P3. And you do that for P4 as well. You take the need and compare it with the new available. If it's true, then you plus it with the current allocation of P4 right here. And you get the 12, 6, 6, 8. And this is the new available and use it for P5 as well. After you get it from P5, this is the latest new available is P5 and the P0 is false, right? But the question tell me to show that the current state is safe. So we need to move back to the P0 right here, P0, and you compare it with the P5 new available, the latest new available. Just now the first new available you cannot compare because it is too small. But the new available you can compare it because it is bigger already. You see, 7 is smaller or equal to 13, yes. 5 is smaller or equal to 6, yes. 3 is smaller or equal to 7, yes. 4 is smaller or equal to 9, yes. So it is true. So you do that again. You take the new available plus with the current allocation of P0 is 2021. And you get 15, 6, 9, 10. So now the process is true, so it's safe already. There is no false process anymore. So in the conclusion, the process safe sequence of execution is from P1, P2, P3, P4, P5 to P0. It doesn't start from P0 because the process is false. So the system is in a safe state, therefore deadlock can be avoided. That's how you check the system is safe state or the deadlock occurs or not. That's all from me. Let's move on to the question number 4, which shown by my another member as I did just now. Let's go.
Hello everyone, I am Uma and I am going to continue with the question number 4. Given the conditional request 3233 from process 5, state if this request should be granted. Explain why or why not. To answer this question, you need to get 3 things: the new allocation, the new need, and the new available. To get the new allocation of process 5, you need to take the current allocation and plus with the additional request. As you can see here, the table, the current allocation is 1011 and the request is 3233. You take the current allocation and plus with the request. And plus 1 plus 3. This be 1 plus 3 and equal to 4. Next, the R2, 0 plus 2 equals to 2. And you continue with the R3 and R4. 1 plus 3 equals to 4. And the last one, 1 plus 3 equals to 4. And that's how you get the new allocation of P5. As you can see here, I highlighted with the purple color that to show that is the new allocation. The highlight with the yellow one is the additional request. Okay, after you get a new allocation, you need to get the new need. To get the new need of process 5, you need the maximum and the new allocation. That's why we get the new allocation first. To get the new need maximum minus the new allocation. The maximum of P5 is 4, 4, 4, 4, and the new allocation is 4, 2, 4, 4. Unit maximum minus the new allocation. Okay, here on the table is 4 minus 4 equal to 0. And next 4, and the new allocation is 2 for R2. 4 minus 2 equals to 2. And continue with R3 and R4. 4 minus 4 equals to 0. And last one, 4 minus 4 equal to 0. That's how you get the new unit for the process 5. And here I highlight it with the light blue color to show that it's the new unit. Okay. Next, you need to get the new available. To get the new available, you need to take the available that you get from the question 1 answer. That is here 6, 3, 5, 4. And you minus it with the additional request from the question 3, 2, 3, 3. I have 6 minus with the additional request. 6 minus 3 equals to 3. 3. Next, for R2, 3 minus 2. 3 plus 2 equals to 1. And for R3, 5 minus 3 equals to 2. And the last one is 4 minus 3 equals to 1. And that's how you get the new available of process 5. That's how you get the new available. The new available is 3, 1, 2, 1. I highlight it with the grey color to show that that is the new available. Okay, next, you need to, if you want to state if the request will be granted or not, you need to execute safely algorithm to check if the system is safe. To check if the system is safe or not, you need the need and the available. You need to check the need is less or equal to the available. If it's true, the system is safe. If false, the system is not safe. For the need, you can take it from the question to answer, and the available you can take from the new available that you get from before. You need to check it one by one. For example, the need of P0 R1 is 7 and the available is 3. Check it. Is 7 less or equal than 3? The answer is false. Next, you check it for second one. Is 5 less than or equal than 1? Is false. If one of it is false, the answer will be false. You need to check one by one. To get answer true, we need to get all of it is true. Then you check for P0, P process 1, process 2, process 3, process 4, and the last one is the process 5. For this one, the need is different because there is an additional request from process 5. Then you need to take it the need is from the new need that you get it from before this one. The new need is 0 to 0, 0. You check it with the new variable 3, 1, 2, 1. Check 1 by 1. For the first is 0, it's less than 3. It is less or equal than 3. The answer is true. But for the second one, it's less or equal than 1 is false, right? The answer is false. That means the answer outcome will be false. To be true, it needs all of it needs to be true to get the output of true. From this, the conclusion is additional request 3233 from P5 cannot be granted. Why? Because the system is unsafe, because its outcome is false. So it cannot provide a safe sequence and will lead to a deadlock. Okay, that's how you answer question number 4. And that's all from me. Thank you.